All right, so I wanted to do a quick video, some dot product examples. The first problem that we're going to do is says determine if vectors u, the component form 3, -2, and v, which is -5, 1, are orthogonal. All right, so we're determining if these two vectors are orthogonal. To do this, we have to remember something, that if dot product is 0, then the vectors are orthogonal. Also, my handwriting's so bad. Also, let's remember, what is the dot product? Well, the dot product of u dotted with v, vector v, is just the components u1 times v1 plus u2 v2. All right, so let's go through all this and see if we can't figure out what if these two vectors are orthogonal. So the way we would do u dot v is we're gonna have, let's see, that's gonna be 3 times -5 plus -2 times 1, which then in turn is -15 minus 2, which is -17. So since it's not 0, our answer is not 0, then we can say that these two vectors are not orthogonal. And it's really that simple. Let's do another problem. Let's suppose that u is the component form -2, -3. And v is 9, 6. Not -6. All right. So if we want to just go through the same thing, vector u dotted with vector v, in this case is going to be -2 times 9, right? Plus -3 times -6, which ends up being -18, 18, which equals 0. So we can say that it is orthogonal. I'll see how quick these are. These aren't really that bad, not hard at all. All right, now another property of, there are a few properties of dot products, that they're commutative, distributive. You can do scalar multiplication on all of these. But one of the more interesting properties is the fact that if I have the vector u, then the dot product of u with itself, so u dotted with u, actually is the magnitude of u squared. So this is one of the properties that we have, and we're going to use it in the following problems. So this problem says use the dot product. So use dot product to find the magnitude of the given vector. I'm going to do a couple examples. This in half. Okay, so the first is we've got vector B, which is 12, 16. Okay, well, let's think about this for a second. If u dot with u is the magnitude of u squared, then the square root of u dotted with itself is just the magnitude of u. So I'm going to use this kind of when doing these problems. So let's think about it. The magnitude of b, right, would be just square root of b dotted with itself. Okay, which means the magnitude of b equals square root of 12 times 12, right, u1, u2 times, or plus 16 times 16, right, u2, u2. Now, given all of that, we can now say, all right, that's just going to be square root of, see, 1, my math serves me well. I think it's 144 and 256, which if you add these two together, it's the square root 400. Or just 20. All right. Okay, second problem is we've got C equals -1, -7. All right. And so absolute value C is the square root of C dotted with itself. Okay. So the value C is the square root of -1, it's -1, plus -7, it's -7, right? Then we've got C square root of, let's see, 1 plus 49, right? Which means that magnitude of C is going to be the square root of 50, which we can break this down into 5 root 2, right? Because this is 25 times 2, square root of 25 is 5. And this is our answer. All right, another useful thing that the dot product has for us is that it can help us in figuring out the angle between two vectors. All right, and for this, let's see, angle between and for this, we have this quick theorem. Cosine theta equals A dot B and of course we're talking about the vectors A and B, over the magnitude of A times the magnitude of B. That's it. Okay. All right. So let's do a quick problem just to prove and show how we do this. All right. So let's say that we've got the vector. Say we've got the vector u and the vector v. Let's say u is the vector -5, -2. And let's say that v is a vector 4, 4. All right. So u is -5, -2. V is 4, 4. Okay. So we're trying to find the angle between these two vectors. So to do that, we can say cosine theta equals the dot product of u and v over the magnitude of u times the magnitude of v. Well, let's break this up. First, let's look at the dot product of u and v. All right, the dot product of u and v, let's see, that's going to be, and I'm just going to kind of do it quickly now that we know how to get it. This is going to be -20 plus -8, obviously u1 times v1, u2 times v2, which gives me -28. It's the first thing that I'm going to do. Okay. The next thing I'm going to do is I'm going to look at the magnitude of u. If you don't remember what the magnitude of u is, obviously it's the magnitude of this squared plus this squared. So this is going to be 25 plus 4, square root of 29. And then the magnitude of v, same thing, square root of 4 squared plus 4 squared, 16 plus 16, square root of 32, or we can say 4 root 2. Either way works out for us. All right. So we've got our dot product, we've got our magnitudes here. All we got to do is put them together. So putting everything together, we end up with -28 all over the root 29 times 4 root 2. Of course, this then gives us cosine theta equals, let's see, -28 divided by 4 is -7, so it's really -7 over 29 times 2 is 58, so the square root of 58. Now, if cosine of theta equals this thing, right, then theta itself equals the inverse cosine of this. So we use our calculator here. And using our calculator, we can determine, so let's see. We want to hit second, then we're going to get a cosine inverse, right? And this is going to be -7 over the square root 58 giving us 156.8. So I would say about roughly 157 degrees. And I would say make sure that, and that is the answer, by the way, make sure that your calculator is in degrees, not radians when doing this problem. All right, the last type of problem that we're going to really be dealing with here is vector projections. a vector projection simply is, let's say we had these two vectors. Let's say we have vector u, we've got vector v. All right. If, for example, I wanted to project this vector on this vector. Let's think about what projection means, right? It's like you think about one of those old time movie projectors, and kind of like we got the little Mickey Mouse ears, kind of looking in the box and this thing. You know, you think about like one of those old movie theaters, right? It's projecting, it's taking the light and everything, pushing that onto the screen. Okay, so if you can kind of think about that in terms of projection, that's what we're talking about here. So if we have, let's say we wanted to project u onto v, that means we're going to take u, more importantly the magnitude of u, right, the length of u, and we're going to stick it down here. Okay. Okay. Obviously, this is not u. We'll call this, I don't know, u sub 1 or something like that. But we're taking this u and we're sticking it onto this vector v. Now, the way we say that, projecting u, so the way to project u onto v is we're going to use this notation. We're projecting u onto little v. Projecting u onto v. And the formula for that is the dot product of u and v, this looks like v, over the magnitude of v squared times the actual vector v. And we'll talk about that in a minute. But let's think about what in the world this does. Basically, all right, we're taking this piece right here, once again, projecting it onto here. I won't go into the specifics of this. For analysis, we're just doing some problems, but you'll see how this can be extremely useful. So let's assume we have assume we have the two vectors v and w, and let's say that v is 1, 3, and let's say that w is 1, 1. And we are asked to find the projection of v onto w. Okay. Well, since this is the case, we're just gonna do the dot product of v and w on the top over the magnitude of w squared times w. Then we're asked to write v as the sum of two orthogonal vectors. Okay. All right. Okay, well, let's do it. So the first thing that I'm going to do is, well, let's just fill in the blanks. So the first thing I want to do is we already know what W is because that's what this is right here. All right. And actually, I'm going to go ahead. I'm going to just keep the notation the same because I don't want to confuse anybody. We already know what that is. Let's go ahead and figure out what V dotted with W is. V dotted with W is going to be, let's see, 1 plus 3, which is 4. And let's see, the magnitude of W squared is just going to be 1 squared plus 1 squared, which equals 2. So that's what we have. All right. So all of that together, we can say this is 4 over 2, and then we're going to take this scalar, multiply it by the vector W, which gives us 2 times 1, 1, which gives our projection of V onto W as 2, 2. Now the second part of this question asks us to write this is the sum of 2 orthogonal vectors. Okay, to do that, we're going to need obviously our projection vector, but we'll need a second vector that's orthogonal to it. And the way we do that is we're going to use V minus the projection of V onto W, which gives us 3 minus 2, 2. And when we think about subtracting the components, right, 1 minus 2 is -1. 3 minus 2 is 1. So if we wanted to write V as the sum of 2 orthogonal vectors, we can say that it is our projection vector plus this difference. And you're done. Hope that was helpful. Don't forget to like, subscribe, do all of the things. Please comment what kind of videos you want me to do. I'm excited to grow this channel, but I need your help. So make sure that you like, subscribe, tell your friends, hit the notification bell, just do all of the things, and I'll see you guys in the next video.